Welcome to this explainer by Forge College. Today, we are taking a massive leap forward. Think back to our previous lesson on configuring mainnet-like environments. You made all those careful decisions, right? But right now, they're probably floating around your desk on sticky notes or buried in your shell history. Well, today, we're going to take those decisions and turn them into a rock-solid, fully reproducible blueprint. No more guessing, no more manual entries. We're building a reliable artifact from the ground up.
So let's start by calling out our main villain for today, which is configuration drift. This is exactly why we simply cannot leave our carefully tuned Solana deployment settings scattered across a dozen open terminal tabs. Configuration drift is basically that insidious little gremlin that messes with your setup overnight, making settings slowly diverge over time. You tweak a timeout here, maybe adjust a retry limit there just to see if a transaction goes through, and before you know it, your local setup is entirely different from your teammates. It's miles away from production, and it leads straight to the absolute worst phrase in engineering, the dreaded, "it works on my machine" curse. And in Web 3, that curse can cost you a whole lot of time and a whole lot of money.
All right, here is our plan of attack for this explainer. First, we'll talk about escaping that configuration drift. Second, drafting your master blueprint. Third, handling environment overwrites. Fourth, verifying your applied settings. And finally, securing repeatable deployments. Let's dive right into Section 1, Escaping Configuration Drift.
You might be wondering, why is setting things in stone, or well, in code, so absolutely crucial for Web3 developers? The secret here is that a single, scriptable configuration completely bridges that massive gap from manual, error-prone choices to full, beautiful automation. When you capture your settings as code, you're effectively putting up an impenetrable fortress against that drift gremlin we just talked about. It guarantees that your test environments are always perfectly comparable to your production-like setups. Plus, it lets you iterate incredibly fast. Imagine needing to tune timeouts or resource caps across multiple testing environments all at once. With a script, it's literally seconds of work. Manually? Yeah, that's just a headache waiting to happen.
Moving right along to Section 2, Drafting your master blueprint.
So, what actually goes into this mechanical marvel we're building? Let's look at our parts list. Our script is going to generate a clean, declarative JSON file populated with a few key fields. First up, RPC endpoints. Now, this isn't just one URL. It's an ordered list, so we get built-in failover, say falling back from a public DevNet to a local instance. Next, we have our retry policy, which defines how many attempts to make and the back-off seconds between them to handle those annoying transient network hiccups. Then we set timeouts to dictate our per-call latency tolerance. We've also got resource limits, like maximum connections, acting as local process caps so your machine doesn't literally catch fire. And finally, the version field. This holds a semantic hash for tracking, which is vital for knowing exactly which blueprint you're currently running. To assemble all these parts, our manufacturing machine is going to be a simple bash script called apply-config.sh. It follows a very straightforward three-step process to stamp out a machine-readable JSON artifact. Step 1, we declare our defaults right at the top of the script. Step 2, we use a multi-line string in bash to build out that clean JSON structure, injecting our variables. And step 3, we write that output directly to a file, specifically into a config/testconfig directory. It's a beautifully simple, highly effective process.
Up next is Section 3, Handling environment overrides.
Let's be completely realistic for a second. What if we need to adjust the dials for a slightly different test environment, but we don't want to tear the whole script apart? Think about the contrast between two different approaches here. On one hand, you have the total novice approach, hard-coding values by opening up the script and editing the file directly every single time you want to make a tiny change. That is a guaranteed recipe for accidentally breaking the script's syntax. On the other hand, you have the professional approach, using environment variables. By writing our script to accept variables, like just typing retry_attempts equals 5 right before executing the script in your terminal, we safely inject new values on the fly. This means your continuous integration pipelines or your teammates can customize the execution completely without ever altering a single line of the underlying code. It's a real game changer.
Okay, Section 4, Verifying your applied settings. It is time for the moment of truth in our drafting room. You hit enter, the script ran, the terminal blinked. But did the blueprint actually work? We can't just cross our fingers and assume it did. How do we definitively know it generated a valid, usable configuration for the Solana DevNet? The secret is verifying these 4 concrete checks. First, we check that the script returns an exit status of 0. In the shell universe, a 0 means perfect execution, no errors.
Second, we have to ensure the JSON output is structurally valid. You can use a fantastic command line tool like JQ to parse it. If it spits out beautifully formatted text instead of an angry red error, you're golden. Third, we actually ping the network. We take the primary RPC from our shiny new file and fire a JSON-RPC get health request at it, just to make sure the network returns an OK. Finally, we confirm our configured resource limits are actually visible and readable by the downstream tools that will be consuming them.
Now, if things go hilariously wrong during verification, don't panic. Just watch out for these incredibly common debugging traps. A single missing comma in your JSON string, yeah, that will render the entire file invalid. Another absolute classic is forgetting the export command in your terminal, which means your custom environment variables just get completely ignored by the script. You also might encounter an unreachable RPC simply because you aggressively hammered a public endpoint while testing, and, well, they've temporarily throttled you. And lastly, failing to capture the configuration version dynamically from Git. If you miss that step, you completely lose your traceability.
And finally, Section 5, securing repeatable deployments. We know our machine works perfectly, we've verified the output, so let's lock this blueprint in the vault. Think of this as a quick 3-minute timeline to build a bulletproof workflow. By sequentially stepping through these Git commands, we seal the deal. Minute 1, get add to stage both your bash script and the generator JSON file. Minute 2, get commit to save that specific snapshot with a crystal clear message. And minute 3, get tag to mark this exact state as, say, version 0.1.0. By doing this, you instantly transform your work into a perfectly reproducible artifact tied to a specific commit hash. If anyone ever needs to recreate this exact environment, they don't have to guess. They just pull the tag. I want to pause on this idea for a second, because this is really a guiding philosophy for senior engineers. Keep configuration declarative and data only so other tools can consume it, and bake a version fields tied to a commit or tag so artifacts are traceable. When your JSON file is just pure data, any tool, whether it's Python scripts, Rust programs, or CI runners, can read it effortlessly. Keep these golden principles of declarative configuration in your back pocket. They are the exact foundation you are going to rely on in our next module when we tackle troubleshooting network issues. I'll leave you with this final thought to ponder today. If your entire environment drifted completely overnight, like you woke up to an absolute blank slate, could your current blueprint perfectly rebuild it in seconds? If you followed along and built this script with us, the answer is a resounding yes. I highly encourage you to head over and explore the extensive programs, courses, and our vibrant learning community at forge.college to master this subject and so many other fascinating Web3 topics. You've just taken a massive step toward professional, automated Solana deployments. Keep building, keep verifying, and I will see you in the next explainer.